right, continuing right along here. Right, so far you have measured angles in degrees. You can also measure angles in radians. So a radian is a unit of angle measure based on arc length. Recall from geometry that an arc is an unbroken part of the circle. If a central angle theta in a circle of radius r, then the measure of theta is defined as 1 radian. Right? So if we think of arc length is central angle divided by 360 times 2 pi r. Here my central angle is theta, so I'm going to replace, oops, to put AL. I'm going to replace that with theta over 360 times 2 pi, and the radius of the circle was 1, right? It was a radius of circle 1, a circle of radius 1, right? So that means my arc length here would be 2 times theta times pi divided by 360, right? And we could simplify that, right? So arc length is theta over 180, and there's a pi in there. So now we have a way to think of radians, because this actually is how to change to radian measures, right? So it uses arc length. We're not going to have to do any derivation. I'm going to give you a formula that you could change arc length. You could change angle measure to radians, right? Because we're not worrying about the length of our radius. We're going to be dealing with a radius of 1. But we need to be able to change this to radian measures. So how many degrees is how many radians? So easy to do this. So easy. All right, converting angle measures, degrees to radians. You're going to multiply the number of degrees by pi over 180. Hey, that's what I had over here, right? Except we have a theta, and in this case, theta is whatever the central angle is. But we're just using, so your theta is whatever your angle is, right? We're going to multiply that by pi over 180. So here, theta is just whatever the angle measure is. In degrees. That looks really sloppy, but I think you get the idea. Okay, moving right back. Come on. All right, so if we want to take degrees and change them to radians, you're just going to multiply by pi over 180, whatever the degrees was. And if you wanted to change radians back to degrees, well, you just multiply by the reciprocal, right? You just undo what you just did, right? So dividing by pi over 180 is the same as multiplying by 180 over pi. Angles measured in radians, by the way, are often not labeled with the unit. If an angle measure does not have a degree symbol, you can usually assume that the angle is measured in radians. And we are going to be primarily working with radians, especially as we graph. As we graph trig functions, it's just going to be radians. All right, so converting radians to degrees. So 180 degrees is pi radians. 360 degrees is 2 pi radians. If you want to go from degrees to radians, you just multiply by pi over 180. If you want to go If you want to go from radians to degrees, then multiply by 180 over pi. All right, and you have this in your notes. You also had this handy dandy little formula sheet here that had your 2 formulas on it. That's in your notes. All right, so here you can see that theta is 180 degrees here, and that is pi radians. If you go all the way around the circle, it's 2 pi. What if you only go halfway around this, or a quarter of a way around the circle? Well, half of pi is going to be pi halves. So that's pi halves radians. What if you go pi radians and you go 1 more half? Well, then you've gone 3 pi halves radians. And actually, these are our key values when we go to graph. We're going to be working with pi halves, pi, 3 pi halves, and 2 pi. But we'll talk about that more when we get to the graphing portion of this lesson. And let's convert. All right, so I have one of these in your notes. Right, so negative 20 degrees, we're just going to take negative 20 and multiply by pi over 180. Right, if you ever forget, so your 20 and your 180 are going to reduce. Just think you got to reduce the 20. So the 180 goes on the bottom, just in case you ever forget. Right, so we could reduce this. We always want to have our fraction in reduced form. Right, so we can cancel out those zeros there. Actually, you know what? I'll write it twice, just so that it's always clear what I'm doing. Right, so there we multiply by the formula, and I'm going to reduce first. And if it helps, you can put a 1 there if if it visually bothers you. We can cancel out the zeros and reduce the 2 and the 18 to 1 and 9. So this is equal to, I'll write it below actually. This is equal to negative, don't forget it was negative, negative pi ninths radians. And we don't have to put a unit of measure. 45 degrees. So we have 45 times pi over 180. And like I said, if you like the 1 underneath, if it visually helps you out, go ahead and do that. We could reduce 45 and 180. Right? So 45 goes into 90 twice. It's going to go into 180 4 times. Right, so in radians, 45 degrees is pi fourths. And that makes sense. On the last page I told you 90 degrees was pi halves. 45 is half of 90, so pi fourths is half a pi halves. Right? And then the last one there, 240 degrees. Right, so again, we're going to take 240 degrees and multiply by pi over 180. Oh, and this should have had a degree symbol on there, but it's not all that important. Right, so we can reduce those two zeros there. 18 and 24, both divisible by 6. This would be 4, and this would be 3. So this is 4 pi thirds radians. And that's all there is to converting from degrees to radians. Pretty easy, I think. Right? That's all there is to it. Let's go the other way and convert from radians back to degrees. What if you needed to go back to degrees? And I put one of them in your notes. You can certainly copy more down, but I just gave you one. I gave you the one in the middle. Right, so 3 pi. Right? So now radian measures, you have smaller numbers than you do with degree measures. Right? So it's 180 degrees, right? That's only 1 pi radians, right? So your numbers here are going to get bigger. So in case you forget which way it goes, it's going to be 180 over pi, because the pi is going to cancel, and you're going to have a larger number than in degrees than you did in radians. Right? So this is 3 pi. There's nothing I can reduce other than, of course, the pi. Right? And so 3 times 180 is going to be 540 degrees. Now we put some units. I put 2/3 pi in your notes. Right? So we have 2. Oh, by the way, the pi goes up here. It's just how it's typed. It's not 2 divided by 3 pi. It's 2 pi thirds. It's supposed to look like 2/3 times pi. And I don't think it quite does that. But this is what it is, okay? It's that. Very different than 2 divided by 3 pi. Right? The pi is in the numerator. Right? So we can do a little reducing here. Oops, and then it helps if you remember the pi and don't stop halfway. Right? So 2 pi divided by 3 times 180 over pi. I'm going to cancel out the pi's, and 3 divides into 60 times. So 2 times 160 is 120 degrees. That's the one you can put in your notes. So when we were graphing 120 degrees a little while ago, we were really graphing 2 pi thirds radians. And then finally 5/8 pi, and that is not 5 divided by 8 pi. That's what it kind of looks like. It is 5/8 times pi. The pi is in the numerator there. And if we want to go to degrees, we have to multiply by 180 over pi. All right, and we can reduce the pi's there. 8 and 180 both divisible by 4. This would be 2, and this would be 45, and that's the end of our reducing. 5 times 45 is going to be 200 and, wait. That's not going to be 220. How about 225? If it was 220, it'd be divisible by 2. 225 divided by 2 degrees, or you could just make that 112.5 degrees, whichever you like better. Okay? And that's all there is to converting from radians to degrees and degrees to radians. That's it. So I'll have a few for you to do at the end of this lesson. Maybe some of those. And I thought we had our little friends here. I think they're coming up after this. Radians versus degrees. So there you can just see. Definitely not something to memorize. Don't waste your time memorizing these. Just note that how easy it is to convert back and forth. The ones you should absolutely know, though, is that 90 degrees is pi halves. 180 degrees is pi. 270 degrees is 3 pi halves, and 360 is 2 pi. Some other important ones are these ones right here. They come from our special right triangle. So these 3 are important. Those are from the special right triangles, right? 30 degrees, 45, and 60. Right? Pi 6, pi fourths, and pi thirds. Not as much in this class, but certainly as you move forward, those are very, very important numbers. So if you could commit those to memory at some point, that would be good. For this class, you should know that one right there, the 90 degrees, the 180, the 360, and the 270. Those are key ones. Those are our quad angles. So those are special right triangles. The other ones here, I'm just going to call them quad as opposed to quadrantal angles. The quad angles. Right? They end up on one of the extra y-axes. Right? Those are important. And those are these ones. Right? So if you could remember those, but you saw, you could always just convert back. Right? But those are ones you should really, really know. I think our friends are coming up here. I thought they ended this lesson. Here they are, Melvin and Philippe. So radians is a powerful measure for curved areas. It is the measure of choice for mathematicians and in trigonometry. So next we'll find trig ratios given angle measures. Says Melvin, I can't wait, says Philippe. Oh, they are so excited. I hope you're excited. See you in the next podcast. Bye for now.